Boyle's Law by Courtney Kemp and Tatiana Bridges. I am Tatiana Bridges, and I'll be presenting Boyle's original. Courtney Kemp will discuss modern applications and will explain the mathematics behind Boyle's Law. Boyle's Law states that the pressure of a gas is inversely proportional to its volume, provided the temperature remains constant. In simpler terms, as the volume of a gas decreases, its pressure increases, and vice versa. Understanding how gases behave under various conditions, gas laws, and the behavior of matter, applications in engine design, air compressors, and vacuums. Robert Boyle, the scientist who formulated the law, was an Irish chemist, physicist, and inventor. Boyle's law was first published in his book, The Skeptical Chemist, in 1661. Boyle's work laid the foundation for modern chemistry and gas laws. He's often referred to as one of the founders of modern chemistry. Boyle used a J tube and a mercury column to measure the pressure exerted by gas at different volumes. The gas was trapped in one arm of the tube, and the volume was measured while adjusting the pressure by changing the height of the mercury column. Limitation of Boyle experiments such as lack of accurate pressure measurement tools, potential errors in the measurement of volume due to imperfection of the equipment. Boyle had to rely on visual estimates rather than precise instruments. Boyle was motivated by the growing interest in understanding the nature of gases, which were still a mysterious substance in his time. He wanted to test whether air behaved like a material substance under different pressure. Boyle's discovery was pivotal because it was one of the first to establish a clear mathematical relationship between pressure and volume. It contributed to the development of gas laws, influencing the work of later scientists like Charles and Gabus. Modern experiments to demonstrate Boyle's law typically use digital pressure sensor, gas syringes, and temperature controlled environments to ensure accuracy. A modern setup might include a sealed container with the gas, where the volume is altered and the pressure is measured using sensors. Modern experiments are more precise. Advancing technology allow for accurate measurements, real-time data logging, and computational analysis, which were not available in Boyle's time. Modern applications of Boyle's law include engineering, designing engines and compressors, medicine, understanding how respiratory system and ventilators work, aerospace, ensuring safety in aircraft and spacecraft cabin pressure. Future research may involve exploring gas behavior at extreme conditions such as space or in the development of new moorings for energy storage that rely on gas compression and expansion. I am Example question. How does Boyle's law affect the behavior of gases in a diving scenario? This is relevant as it appears Boyle's law to real world situations, explaining how gas volume changes with depth pressure underwater. Understanding how Boyle's law works underwater helps divers calculate how pressure affects air supply and how to avoid dangers like decompression sickness, the bends.
The question was formulated based on the application of Boyle's law in diving, specifically exploring how gas behaves in response to pressure changes as a diver descends or ascends. This question is unique because it connects Boyle's law to a life critical scenario in diving, demonstrating its practical application beyond theory. Here we show an example question. Conclusion. Boyle's laws use in determining how balloons behave at different altitudes. Gas laws are foundational principles in understanding the behavior of gases. With Boyle's law playing a key role in this area, it sets the stage for further investigation into how gases behave under various conditions. Grasping Boyle's law is essential across multiple fields, such as meteorology, engineering, and medicine, where it has practical applications. Tatiana is interested in space travel. Boyle's law helps in understanding the behavior of gases within spacecraft cabins, ensuring proper pressure regulation for astronaut safety. Sources